Welcome to This Explainer. I am so thrilled to have you here today because, well, we're going to dive into a massive paradigm shift that's literally happening right above our heads. For decades, we've thought of the space industry purely as the domain of rocket scientists with these massive, bottomless government budgets. But what if I told you the future of space isn't actually about building better hardware? It's about writing better software. Right now, digital twin technology is completely rewriting the business model of the space industry. It's taking a notoriously difficult physical market and turning it into a highly scalable digital ecosystem. So if you're an IT engineer, a founder, or honestly just someone fascinated by where cutting-edge tech meets real business, you are in the exact right place. I want to kick things off with this incredibly blunt quote: technically difficult, high barrier to entry, and unprofitable. Ouch, right? But this brutal, honest assessment of the legacy space industry comes directly from Koyo Sato, the CEO of Space Data. He actually delivered this reality check at the recent Spacetide 2025 conference over in Tokyo. And what makes Sato's perspective so crucial for us is his background. He didn't start in aerospace at all. He actually spent 15 years in the IT industry before looking up and identifying space as the next ultimate frontier. Looking at it through the lens of a software entrepreneur, he saw an industry that was, sure, scientifically brilliant, but commercially, totally broken. Okay, let's dive right into this roadmap. First, we'll look at the limits of the space business. Then, the digital twin solution. After that, monetization through simulation. And finally, dual use and the future.
So, part 1, overcoming the physical bottlenecks.
Before we can really appreciate all the cool software solutions, we have to establish the core business problem that engineers and founders are slamming into today. Sato makes this powerful analogy. He says that for the space industry to survive commercially, it absolutely has to become as accessible and democratized as the internet. The old space industry, it is vastly over-indexed on scientific discovery. It relies almost entirely on physical rocket launches, which creates these astronomical financial barriers to entry. On the flip side, look at the internet industry. It's democratized. It's digital first. Literally anyone with a laptop can build a highly scalable product. Sato's mission is to bridge that gap. He wants to rip space out of the exclusive hands of aerospace conglomerates and put it right onto the screens of developers worldwide. The crucial point here is simply this: physical dependence absolutely kills scalability and profitability. Think about it from a startup or an IT engineering perspective for a second. In software, if you want to test a new feature, you run a simulation, compile your code, and boom, instant feedback. But in the legacy space industry, if you want to test a new robotic arm or a sensor, you have to build a multi-million-dollar physical prototype, wait months, maybe even years for a launch window, strap it to a rocket, and just pray it doesn't explode on the launch pad. As long as your testing requires launching physical hardware into orbit, iterating quickly, which is the absolute foundation of modern tech business, is impossible. You just cannot scale a business model that is entirely bottlenecked by physical launches. Which brings us to part 2, the virtual pivot. This is where the business model gets a massive, massive upgrade. We are shifting development from the physical, harsh vacuum of space to a purely software-driven environment. Enter the concept of the virtual experimental ground. This is exactly what Space Data is building. It's a highly accurate, photorealistic simulated environment. For instance, they've built a full digital twin of the International Space Station, interior and exterior. And this isn't just a video game, okay? It's an engineering-grade space robot simulator. This means an IT engineer sitting in a coffee shop in Tokyo or San Francisco can write code for a space rover, deploy it into this virtual ISS, and test its behavior in zero-gravity conditions with complete accuracy. You are effectively decoupling space development from the rocket launch. Let's actually look at the tech stack making this possible, because this is where IT engineers can really find their footing. Step 1. Generative AI is used to automate the creation of these massive, complex 3D models. I mean, you couldn't build this by hand fast enough, so AI does the heavy lifting of generating the virtual worlds. Step 2. High-speed physics engines are layered in to accurately simulate the unique environmental conditions of space. We're talking gravity, lighting, material physics. Step 3. The platform is opened up globally. Space Data calls this overarching vision planetary computing, the idea of calculating and simulating the entire environment of our world and beyond. It totally transforms space development from a hardware manufacturing nightmare into a pure software engineering opportunity. Moving right along to part 3, monetization through simulation. Okay, if you're a founder or an investor listening to this, you're probably asking the million-dollar question right now. Who is actually paying for this today?
Well, the sheer brilliance of this model is that they aren't waiting for some massive space economy to magically materialize decades from now. They are monetizing the simulation tech right here on Earth, right now. Space Data is currently working with the United Nations running disaster prevention simulations across more than 1,800 cities globally. They're also deeply integrated with the Japanese Ministry of Land, Infrastructure, Transport, and Tourism's Plateau project, which creates these incredible 3D models of real-world cities. By taking their massive simulation engines, which, remember, were originally built for space, and applying them to these terrestrial models, they can run highly complex virtual, social, and human life experiments. They can simulate floods, optimize traffic, and plan urban development with unprecedented accuracy. And that right there brilliantly illustrates the real business genius of the digital twin pivot. It's space technology repurposed today to protect human life and earthly infrastructure. As a business model, it is absolutely incredible. You are taking the high-margin, highly scalable software infrastructure built for the next frontier, and you are applying it to immediate, urgent, and well-funded terrestrial problems. This proves immediate return on investment. It completely shifts the space business from being this speculative, money-burning research project into a highly lucrative B2B and business-to-government software-as-a-service model. Finally, let's look at part 4, expanding the market ecosystem. To truly scale this new space ecosystem, Satayo highlights the concept of dual use. Now, purely from a business and market expansion perspective, dual use refers to the mutual transfer and utilization of advanced technologies between the civilian or industrial sector and the security sector. Historically, space was purely a science play. Then it slowly opened up to some commercial industry. But now, by intentionally building digital infrastructures that can serve both civilian urban planning and national security disaster readiness, you are massively expanding your total addressable market. It is just a highly pragmatic strategy to make sure the technology is self-sustaining and widely adopted. To see how this all comes together, just consider how things used to be. Science, industry, and security were completely siloed off from one another. They operated totally independently, which made the whole endeavor largely unprofitable and super difficult to enter. But through the power of digital twins and planetary computing, these 3 domains are now fused into a single, self-evolving ecosystem. Science provides the data, industry builds the scalable commercial software, and security provides the critical, funded use cases that protect our infrastructure. This fusion was actually a central takeaway from the 10th anniversary of Spacetide, this realization that the space industry can no longer just be about science. It has to be an integrated, accessible ecosystem. Which brings us to our final thought for today. The democratization of space is no longer just some distant sci-fi dream. It is actively happening right now through code, simulations, and digital twins. The old physical barriers are quite literally being dismantled by software. So I want to leave all the IT engineers, founders, and innovators tuning into this explainer with a direct challenge. If space is truly becoming the next internet, a democratized digital-first platform, what service will you build in the virtual cosmos? Thank you so much for joining me on this deep dive, and keep innovating out there.